Okay, in the last section, we talked about translations and rotations. And if just to jog your memory, translations were just where we slid an object, right or left, or maybe up or down. Um, and then we had rotations. Rotations was where we moved it through an angle, so we sort of twisted it. In this section, we're going to add two more movements to our list. We're really going to be focusing on one and just kind of briefly talking about another. The one we're going to focus on here is a reflection, and this really means exactly what you think that it might. You're reflecting something about a line. You can think about it as kind of like a mirror image, flipping something, some figure or some object across a line. Let me show you what that's going to look like. Here we have a quadrilateral, and we're supposed to flip it about this line here. So I'm going to take and I'm going to look at this point by point. If I flip this point about the line, it is its own flip. There's nowhere for it to go, so it's by itself. And then I can start looking at point by point and seeing how far away it is from the line and which direction. So this is like diagonal across the line. So if I look diagonal the same distance on the opposite side of the line, I would be here. For this point, I would be here if I flipped it across. For this point, I would be here. And for this point, I would be here. So when I play connect the dots, it looks something like that. So that is what happens when I take and I flip this image across that line. It would be picture A. Now, what about a double flip? What would that entail? So here we have one that says determine the final result when triangle ABC, here's triangle ABC, is reflected about the line L, and then that image is reflected again in L. So we're doing a double flip here, flipping across L and then flipping back across L. Well, can you see that that would put us exactly back to where we started? So that would be B. Okay, now some of you guys have had college algebra before, some of you have not. If you've had college algebra before, you should remember working with symmetry. And if you haven't had college algebra before, then hopefully when you get there and you start talking about symmetry, this will help you to understand what they're talking about. But in college algebra, we reflected or flipped points about the x-axis, the y-axis, and the origin, and we called it x-axis, y-axis, and origin symmetry. So let's kind of take a look at what that looks like. If I were to draw out a point, let's say 2, 4. Let's make the point right there. There's the point 2, 4. If I were to take and flip this across the x-axis, then that would put that point equidistant from the x-axis but in the opposite direction. So this point here would be the point 2, negative 4. Can you see that in order to flip things across the x-axis, all we do is replace the y-coordinate with the negative or the opposite of y? If I want to take and flip this point across the y-axis, then that would put me right about here. So that, if I name that point, that's the point negative 2, comma 4. So in order to reflect a point about the y-axis, we replace the x-coordinate with negative x, or the opposite x. We don't always want to think about this as being just negative. It means the opposite of whatever the x value was. And then finally, to reflect a point about the origin, if I were going to flip this across the origin, that would put me right about here. And then that point would be negative 2, negative 4. Notice I've changed the signs of both the x and the y. Now we also had what we talked about in college algebra as being inverse functions. And inverse functions were nothing more than reflections or flips about the line y equals x. And if you'll remember from then, all we did to create an inverse function was to interchange the x and the y values. So everywhere we saw an x, we would replace that with a y, and everywhere we saw a y, we would replace it with an x. So these are really important things to know because they carry over from college algebra, and you see them also in geometry. Okay, so let's look at an example. This one says given the point 8 comma 9, that should be a comma, not a period there, sorry about that, reflect the point about the x-axis. So in order to reflect the point about the x-axis, we replace the y-coordinate with the opposite y. So that would be the point 8 comma, and then the opposite of 9 would be negative 9. So that would be our point. Now we're also going to take that original point, 8, 9, and reflect the point about the line y equals x. So to reflect a point about the line y equals x, we interchange the x and the y values. So instead of x, we're going to use the y, which is 9, and instead of y, we're going to use the x, which is 8. So we just flipped those points. Now the last of those transformations that we're going to be talking about is called a glide reflection, and we're just going to kind of briefly talk about that because it's really just a combination of two transformations. A glide reflection is where you reflect the image and then do a translation on it, or vice versa. For instance, here's a picture of one where we've taken this footprint and slid it up. That's the translation where we just slide it, and then it's been flipped about this line. So that's the reflection part. Here we have the glide, and here we have the reflection part. So it's really just two transformations put together. I've also included on the last page here a kind of sheet thing that talks about all of the transformations in one sheet. We have the translation where it just moves a figure in a straight direction. It doesn't change the direction of the figure at all. It just simply moves it left or right, up or down, or diagonally. Then we have a reflection, which is the mirror image, and that does change the shape, not the shape, but it changes the direction of the shape. Then you have your glide reflection, which is a reflection and a glide at the same time. And then a rotation is moving about a point or through an angle.